So this is just video B for 8th grade, lesson 1-6. And the I can statement today, I can compare irrational numbers. That's it. Real quick though, what does this word compare mean in mathematical terms? It means you're going to be using symbols like this. If I gave you the number 2 and 5 and asked you to compare them, you would say that 5 is greater than 2. And that's all we're doing. We're going to compare irrational numbers and expressions that contain irrational numbers. And then finally, we're going to order them from least to greatest, which is kind of the same thing as comparing them. So I'm going to give you 2 examples for this lesson, and I'll make them as fast as possible. So if I have the square root of 3 plus 2, and then I want to compare that against the square root of 2 plus 3, I need to do some calculations. How am I going to tell whether this thing on the left is larger than the numbers on the right, or whether they're equal to each other? Before I get started though, let me just quickly review with you what irrational numbers mean. They're numbers that can't be written as a fraction because their decimals never repeat and they never terminate. They just go on forever. One example of a rational number that you're going to need to understand besides square root of non-squares is pi. And you guys can use, and I do want you to write this down, an approximation for pi that would be smart to use is 3.14. So write that in your notes. Pi is approximately 3.14. I'm going to erase it here and get started with this example, so pause it if you haven't written it down yet. Okay, so what are we going to do here? Well, we got to figure out what the square root of 3 is, approximately, and what the square root approximately of 2 is. Do the additions and see which one appears to be larger. So we know that the square root of 3 and 2 fall between 1 and 2. The reason we know this is 1 squared is 1 and 2 squared is 4. And 3 is less than 4 but greater than 1, and so is 2. So because of this, we got to do a little guessing and approximation like we did in the last lesson. So for 3, I'm going to guess a little closer to 2. I'm going to guess like 1.8. I'm going to square 1.8 real quick and see what I get. 8 times 8 is 64. 8 times 1 is 8 plus the 6 is 14. 1 times 8 is 8. 1 times 1 is 1. Add them up. Okay, so I got 3.24. So I'm going to keep this sort of a log of the information that I find. And you know, it might be smart of you guys to, since you're approximating so many of these, to sort of keep track of what you've done in like a nice little table. Oh, 1.8 squared is 3.24. And that way, you never have to redo that if you come across another problem that you need to know what 1.8 squared is. Okay, so let me try 1.7 and see what 1.7 squared is. 7 times 7 is 49. 7 times 1 is 7 plus 4 is 11. 7 and 1. Add them up, 9, 8, 2. So 2.89. So 1.7 squared equals, oh, I'm getting sloppy. Sorry, let me fix this. My pen is giving me challenges today. So 1.7 squared is 2.89. Okay, so then we know that the square root of 3 falls approximately between 1.7 and 1.8. So I'm going to round this off. I'm going to approximate this to be 1.75. And if you're uncomfortable with that, you need to go rewatch the last video because you've got to know how to do that for this lesson. So that's got to be between 1.7 and 1.8, so 1.75 is a good estimate. We add 2. We still have a question mark here. We don't know whether we're going to use this symbol, or this symbol. But we still need to approximate the square root of 2. So I'm going to try, the square root of 2 is like way closer to 1 than it is to 4. So I'm going to try like 1.2. I'm going to see what 1.2 squared is. 2 times 2 is 4. 2 times 1 is 2. And 2 and 1. We add them up. We get 4, 4, 1. So 1.2 squared is 1 and 4400. That's a little bit on the small side. So maybe I guessed too small. Let me try 1.3 squared. 3 times 3 is 9. 3 times 1 is 3, 3 and 1. Okay, so 1.3 squared is 1 and 69/100ths. Oh, we're getting closer. I better try one more, 1.4, just to be on the safe side. Okay, 1.4 times 1.4, 16, 4, 1. Oh, now we're getting close. So 1.4 squared is going to equal 1 and 96/100ths. So I know that 1.5 squared is going to equal more than 2 because this is so close. And because I know that, I can approximate this square root of 2 at 1.45. Because 1.5 squared, you'll see, will be more than 2. 2.25. More than 2. Okay, sweet. Now that we did all that hard work, we've approximated our square roots. We just do the addition and see kind of where we come out. This would get us 3 and 75/100ths. And this would get us 4 and 45/100ths. So we can go back to the original problem, and we can say with confidence that, and I'm going to erase this 4 because that's really bugging me how sloppy that is. We can say with confidence then that the square root of 2 plus 3 is more than the square root of 3 plus 2, because our approximation came out way more than our approximation of the one on the left. So that's all there is to it, guys. And I know this looks sort of intimidating, but I had to guess and check a lot. I made some bad guesses on the square root of 2. I did that on purpose so you could see what I did. So if you make a bad guess like, oh, 1.2 squared is only 1 and 44/100ths, keep going. Show some perseverance. Don't give up. Don't be lazy. Just because you have to do some quick multiplication doesn't mean you can't solve these. I do not want to see you just guessing. I want to see the work for these. You guys can approximate, I promise. And save some of your approximations. Like there's going to be other problems where you have to deal with the square root of 2 and the square root of 3. So once you've approximated those, save that information for your later problems. Okay, good luck to you. Oh wait, there's one more example I have for you. Sorry. Okay, here's my last example, if I can get my pen to work. There we go. Ordering from least to greatest. If you have to order irrational numbers from least to greatest, first thing you want to do is you want to approximate all of the numbers, all the irrational numbers. Approximate all the irrational numbers. So if I've got the square root of 7 and I've got the square root of 8 divided by 2 and this just 2, I need to approximate these two numbers in the middle before I put them in order. So I would approximate the square root of 7, then I would approximate the square root of 8, divide that by 2, and then I would put them all in order and see where I end up. Just as a quick side note, I know that the square root of 7 is going to fall between 2 and 3 because 2 squared is 4 and 3 squared is 9. Same with the square root of 8. So this is going to be an interesting problem to do, and I'm going to let you guys do it. After you approximate all the irrational numbers, put them in order. I'm not going to do this for you because I know you guys can do it. It's just like the ones back here, the first one we did. There's nothing really different about it except you have to put 3 of them in order. So you have to approximate all of them and then put them in order. I will say one thing though. In your final answer, use the numbers that they gave to you originally. Don't use your approximations. So for example, I don't want you to say, 2 point whatever you end up getting for this. I want you to use the square root of 8 divided by 2 when you order these. All right, guys, good luck.